Hello, this is Christopher Rose, senior client network engineer here at MCNC. You might hear a slight echo there. We're testing just to make sure things are working here. Welcome to one of our summer webinar series. This particular webinar, we're going to talk about troubleshooting traffic flows through Cisco ASA firewalls, which I know quite a number of you probably have, because that's the ITS managed firewall. Thanks, Dave. I got your message there that you can hear me. So I guess let's go ahead and get started. So kind of briefly here to the agenda as far as what we're going to talk about in this webinar is the first thing we're going to do is we're going to cover some just firewall best practices. These are essentially just best practice type things that you should be doing if you're responsible for maintaining a firewall. If you follow a lot of these best practices, you probably won't find yourself in the position of having to do a whole lot of troubleshooting. And it's one of those an ounce of prevention is better than a pound of cure kind of thing. We're also going to talk about the ASA Monitoring-Administration Tools. There's a couple of different ways that you can do that kind of stuff. Cisco gives you some options there. We'll talk about those. Next, we'll talk about what a typical traffic troubleshooting scenario is going to look like, for your typical user using some type of cloud service. They're having an issue, they can't get connected, that kind of thing. Then we're going to talk about, how do we perform packet traces to check for issues through the firewall. Basically, we'll be walking you through how to do a packet capture and then how to take a look at that and look for issues. Or packet trace, I'm sorry. Packet capture is the next thing we'll go over. Basically, your primary method of troubleshooting connectivity issues through the firewall is going to cover essentially one of these two activities. You'll either be doing packet traces or packet captures. And then lastly, we'll kind of go over where to go for more information if you have additional questions, that kind of thing. And then towards the end here, I'm going to try to leave some time open so that I'll be able to take questions if you guys have that. So if you guys have like specific issues you're having now that you have questions about or that kind of thing, then we can discuss those. Kind of a prerequisite here is a lot of the tools that we're going to talk about using. In order to do this, you will need to have administrative access to your ASA in order to perform some of those functions. I know there are a number of you that may have ITS administered firewalls and that you may not have administrative access. ITS does offer some access in that you can get in through ASDM and you can kind of look at some things, but in order to actually be able to do packet captures or packet traces, you will have to have administrative access to your firewall in order to do that. So let's talk a little bit about firewall best practices. And I've kind of broken these up by category. I've administered firewalls for a lot of years. Probably a little over a decade I've been messing with ASAs. And these are I guess what the industry would say are best practices as far as just kind of general advice on how to maintain firewalls so that you keep your sanity as far as knowing what's going on and what's in the configuration at any given time, and reducing the number of problems you have to troubleshoot. So the first category is kind of security zoning related. And when I say security zoning, essentially what I'm talking about is making sure that you have your network broken up into multiple security zones. So you kind of group hosts or servers together that have similar security attributes. And most of you will know that kind of setup is like your typical inside zone, outside zone, DMZ type zones. And in this category here, I have, use a DMZ if possible for public servers. So like if you have things like Moodle servers, web servers, FTP servers, that kind of thing, and they're exposed to the public. Instead of punching holes from the outside directly to the inside of your network, just make sure you have those hosted in DMZs that have limited access to your inside, and that way, if you get, it's basically protection against hacking. And then use AnyConnect VPN when possible in lieu of direct remote outside access to internal hosts. A lot of times what I'll see when doing network assessments is I'll see folks that have RDP from servers directly on their inside host or in their server DMZ that are connected directly to the outside, so that they can get remote access from home. And basically what that does is that opens up the machine for anybody on the internet to sit there and bang away on it, until they get access. It's a lot easier, and it's a lot safer to basically use AnyConnect VPN and force folks to log in through a VPN in order to get to that and use encrypted connections. Some of the other best practices here, like, are rule set related, because the rule sets on these firewalls are where you're going to wind up spending most of your time. When you're making rules, be as specific as possible. Basically take a least privilege approach as far as designing your rules. Try to avoid using any type rules. Typically, kind of a rule of thumb I use is I don't really want to see any in more than one of 3 places, as far as either source, destination, or port numbers. If I see 2 any's in a rule, then, that's, to me, that questions whether that access level can be tightened up a little bit. Another thing is basically just allow only essential services to the internal zones. Ingress filtering, basically that's filter stuff coming from the internet going, into your servers, least privilege type thing. And basically only allow essential services out to the internet, or egress filtering. Basically, folks on my inside network going out to the internet, I really should only be allowing them out on business required ports. And this cuts down on a lot of BitTorrent and things like that can kind of create headaches for you. Document your rules for later review. Can't overemphasize that enough. How many times folks will put things in a firewall and forget why it's there. Make sure you use good naming conventions when you do that, and make sure you leave your comments in there so that, like I said, so that you know why they're there. And try to use groups in your firewall configuration on the ASA as far as network objects and ports. It makes making the rules a lot easier, in that you can kind of reduce the number of rules that you have to do when you do that. And then lastly, just perform regular housekeeping, including, periodic rule reviews and removal of unused rules. I see a lot of firewall configurations and network assessments, and you can see a lot of times where there are rules that have kind of been left in there that really don't do anything anymore. A lot of that is just people fail to perform regular housekeeping on these configurations, and it can kind of make things confusing, and it can also leave security holes open, especially like if a server moves or is decommissioned, that access is still left in the firewall. You put a new server in on that same IP address, it could get ugly. Monitoring is another area of best practice. Make sure you're logging your events, as you need to, so that you can go back and look for problems, or, just kind of keep tabs on what's going on. Monitor your load on the firewall as far as, memory, CPU, bandwidth for capacity planning purposes. And then use your firewall to help you troubleshoot network issues when you have connectivity issues or other issues on the network. Because your firewall can do packet captures and things like that, sometimes it can be a really useful tool as far as trying to troubleshoot connectivity issues. So now let's talk a little bit about tools that the ASA has that can help you as far as being able to troubleshoot connectivity issues. The first is the one that all of you are probably familiar with. It's the ASDM. Basically, it's a GUI tool for administering and monitoring the firewall. And within the ASDM, there are a lot of different subtools too, and I call out just a few of them here because these are the ones that we're probably going to find the most useful when we're trying to troubleshoot something. The first of them is Packet Tracer. The next would be Packet Capture Wizard, the Syslog Viewer, and the ping and the traceroute functions. For those of you who are feel really at home with command line stuff, especially if you're like an old school Unix admin, you can get SSH access to the firewall as well, and there's a command line there that's very, the syntax is very similar to Cisco routers and that type of thing, in that the tools you have there are essentially, you can do show commands, you can do debug commands, ping and traceroute as well. Now, I have also on this list here a Syslog server. It's not absolutely necessary, but it's very nice to have. And the reason why is because there are a lot of times where going through that Syslog, going back and being able to look at historical messages can kind of help you find problems that may have been occurring before you noticed anything was happening. And depending on how you have that configured, as far as how long you're keeping records and things, it can be useful for other things as well, especially if you need to do like forensic auditing or things like that. The other nice thing about it too is I have found sometimes the Syslog viewer in ASDM doesn't always, occasionally it'll get hung and I'll have to stop it and restart it. Sometimes it's just nicer to be able to get on the Syslog, know that stuff's there, and be able to, do a search and find what you're looking for. If you don't have a Syslog, I would actively encourage you to set one up. There are freely available ones. I believe Kiwi has a free Syslog server that will work on Windows that you can do up to 5 devices, so you'd be able to do your ASA. And especially when you have an ASA that's very busy, like if you have, like a gig worth of traffic going through it at any given time, the Syslog stuff will scroll by so fast that, sometimes having that server where you can go in and search for it, is really helpful. So let's talk about a typical traffic troubleshooting scenario, and this is the typical kind of thing that you'll run into as far as customers. And you can see our little customer in the picture here, who basically can't get to his FTP server, and as you can see, it's really just ruined his day. On here we have the client PC, and then typical setup in that the PC is usually connected to a distribution switch, which is then trunked back to a core switch, which then gets fed out through an ASA firewall, which then goes out through the internet to whatever cloud or internet service he's trying to connect to. In this case, it's an FTP server. And a lot of times the way these will come in is someone will call you and be like, I can't connect to this or that or whatever. Well, how do we troubleshoot this? So before we start talking about troubleshooting, one of the things I want to do is just kind of give some cautions about using ping and traceroute as troubleshooting tools. And I threw this in here just because I've had many personal experiences where I've been trying to troubleshoot traffic issues, and I have been led astray by ping or traceroute results. And I've seen other people, sometimes they get kind of wrapped around the axle and looking in the wrong place because they put a little too much faith in the results of these tools. First thing to point out is not all devices in a network path will reply to ICMP or UDP protocol requests. Depending on how the routers or the firewalls are configured, if ping isn't turned on those, sometimes they won't respond. They may be up and they may be passing traffic, but they won't reply to your ping. The other thing I'd point out too is that Traceroute works differently on different operating systems. In Windows operating systems, Traceroute uses ICMP, and on Unix, it usually uses UDP. Two different functional methods as far as how they get their results. In some cases, you may run a Windows Traceroute and it'll work, and the Unix one won't, or vice versa. Sometimes the Unix one may work because it's using UDP, but the Windows one that uses ICMP messages won't, because those are either being blocked by the firewall or the devices in the path won't respond to that. So kind of the general caution, on these, from at least from my standpoint, is, information from these two tools is useful, but packet captures and logs are really still the gold standard for verifying connectivity. So basically, when you use ping and traceroute, always remember you just kind of take it with a grain of salt, and try to realize that, like I said, sometimes devices in the path won't reply the way you think they will sometimes. The other thing I would point out too is, beyond just being able to turn ICMP reply on and off, on some devices, it's given a lower priority than traffic processing. So there may be times where it will skip replying to pings or things like that if it's busy doing other stuff. So let's talk a little bit about kind of a simplified approach as far as thinking about how ASA traffic goes through a firewall. And this is an approach that I was taught many years ago by people who mentored me, and I found through my career this has actually worked really well for me. Basically, when the ASA is processing a packet, when the traffic goes on the inside interface, goes through the ASA and goes out on the outside interface, the ASA kind of goes through a process internally. Typically, the first thing that will happen when that packet hits the inside interface is, because that's the ingress interface, the ASA is basically going to check that traffic against an access list. And if it's denied by an access list, it's going to drop the traffic. If it's allowed, obviously, then it moves to the next step. Then usually the next step that happens is the ASA wants to know if there's a valid address translation, basically a NAT or a PAT rule that's in place that will tell the firewall, basically, okay, I need to take this packet, translate its private IP address to this public address, then send it out. If there's no valid NAT rule or PAT rule, it will drop the traffic. If it is valid, then it will move to the next step. And the next step is typically looking up a route for that packet once it's been translated. The ASA will need a valid route to know which interface to send it through, and basically what the next hop is. So kind of think of it as a simplified, basically, if I've got a problem and I want to say, like, I want to log into my ASA and just desk check the config to see if it's valid, basically first thing I do is check for access lists on the inside interface or the outside, depending on which direction the traffic is initiating from that you're having problems with. The next thing I'll do is check and make sure that there's a valid translation in the configuration for the traffic I'm trying to troubleshoot. And then the last thing I'll do is check to make sure that there's a valid route. Now, there are additional things that the ASA will do depending on how complex your configuration is. If you're into modular policy frameworks as far as QoS and things like that. But I find these three simple rules as far as, checking traffic flow through an ASA will cover probably close to 99% of, any traffic that you have flowing through an ASA firewall for just average day-to-day use. So what I've done here with this slide is I kind of broke out troubleshooting network traffic flow through an ASA as kind of a stepwise process. And I put this in here too so that if when you're in the process of actually doing this yourself, you can kind of come back and refer to this slide. The other thing I did in parentheses after the actual statements was I put the actual tools that you would use as far as performing that particular troubleshooting step. And essentially what this is basically a walkthrough of that slide earlier where the guy's having problems on the inside network getting out to his FTP server. So basically, how do we go about troubleshooting that? Well, the first thing we want to do is we want to establish that traffic is getting to the ASA from his host machine. And there are a number of ways that we can do that. We can ping the firewall from his workstation and see if we get replies, if the firewall is configured to reply. we can do a packet capture basically at the firewall inside interface to see basically if we see his traffic coming into that interface. You can also use the Syslog viewer in that you can go in and look, and if his traffic is hitting the interface, you will see Syslog messages to that effect. The next thing we do is check that the traffic is not blocked on the ingress interface by an ACL. This is part of that three-step process basically I was just talking about before. And you'll see the next two items after that is basically check that there's a valid NAT rule and check that there's a valid route. There are a number of ways of doing that, but the most popular way of doing all three of those in one quick, easy swoop is to use the packet tracer function on the firewall, because essentially what it's going to do is simulate that packet flow through the firewall and tell you if there's a problem with any of these three things. You can also look at the syslog for these three things too, because all of those activities when the packet's rolling through the firewall will produce various syslog messages. The next thing we'll do, once we're sure all that stuff works, is, we want to establish that correctly translated traffic is leaving the outside interface. That is mostly done by packet capture, on the outside interface of traffic leaving the firewall and then returning back. And that kind of goes hand in hand with the next one after that, which is, we establish that traffic is reaching the intended source, i.e. the FTP, in this case, the FTP server that's out on the internet. And I put in parents here, you may need support at the server end to verify this, because typically the way you're going to verify that it's getting there is you'll either see return traffic coming back from that server, or in some cases, if it's not replying, you may need somebody on the other end to actually log into their, that FTP server or whatever and look and see if they can see your traffic getting to that FTP server. Then after that, what we want to do is establish that return traffic from that server that our user having the problem is trying to get to is actually coming back from the server and reaching the ASA outside interface. And the way we accomplish that is using a packet capture. We can also look at the syslog again, just because we'll see messages to that effect that traffic is hitting, that return traffic's hitting the outside interface. And then kind of the last step in this process is basically just to establish that return traffic is making it back through the ASA and egressing the inside interface of the firewall. Basically, it's coming back out the firewall. The return traffic's coming out of the firewall inside interface and headed off to your core network to go back to your client. And if that sounds a little complicated, and I know we haven't gone through all of these tools as far as how to use them yet, again, I kind of put this here as a reference you can refer back to a little bit later in the presentation here. I'll give you a more simplified version of this that kind of fits along with the scenario I was describing as far as our user that has a problem. So let's talk a little bit about packet captures. Like I said before, packet captures and packet traces are probably going to be the tools you use the most often on the ASA as far as troubleshooting. So the ASA has a GUI packet capture wizard in the ASDM to help you properly configure the firewall to do a packet capture. And the other thing it does too is it makes it a lot easier to get that capture downloaded off the firewall for analysis in Wireshark or whatever. You can do packet captures at the command line, but they are a lot more complicated to perform, in that in some cases you'll have to create some ACLs sometimes. The other thing is you'd have to manually FTP to or HTTP to a specific place on the firewall in order to download those. I find it's a lot easier when doing packet captures to just use the packet capture wizard, because it does all this for you, and then when you're done it also removes all the commands so that you don't have to go back in there and clean up after yourself. The other thing to remember about packet captures is you can customize these things. They're very customizable as far as the traffic they will capture, and the reason you want to, that's a good idea is because when the ASA is capturing those packets, it's basically storing them on the local file system of the ASA in a file. And the flash storage space on most ASAs is fairly limited, so you want to try to avoid capturing, a whole lot of extra traffic that you don't really need as far as trying to figure out what's going on. Especially in some of these larger firewalls, that have like gig interfaces and actually have a gig of throughput, you can quickly overwhelm, the file system space if you're capturing all the traffic. So what we're going to do now is I'm going to kind of give a little demo basically here where I'm going to demonstrate how to use the packet capture wizard on the ASA through the ASDM. So I got to get out of this mode and pop over here to our ASA here. And hopefully everyone can see that. So this is an ASA that we have set up in the lab. And basically it's a test box. So what you're going to want to do when you want to do a packet capture in ASDM is go ahead and get your ASDM up and get logged in. You're going to find it up here under this wizards, up here in the toolbar menu. And basically what you're going to want to do is go over here to packet capture wizard and go ahead and start. And basically what this is going to do is this will walk you through the process of creating that packet capture. So we'll just click next here. So the first thing you're going to want to do is select your point of ingress, basically which interface is the traffic I'm trying to figure out coming from. By default, it's going to pop over to DMZ. Now, this is a little gotcha that I can tell you about just from my personal experience is if you set this to like inside interface here, and then down here you'll see where it says packet match criteria. Basically, this is where we set the filtering to get just the packets we want. Once you set this up here to inside, if you go down here and say specify packet parameters, you'll notice it pops this right back to DMZ. I think that's a bug in the program, and it has tripped me up several times where I've set this to inside and then I've gone down here and tried to put my parameters in and it flipped this to DMZ and I didn't realize it, and then I had to start all over again when I wasn't getting the traffic that I thought I should be getting. So fair warning, probably want to go ahead and set your packet match criteria first. At least set the this radio button down here to this before you set this to the interface you want. So in this case, in our example, I'm going to be using a Windows XP virtual machine that I have set up in the lab, and I'm going to be doing FTP of some files basically from the NC State Linux distribution server where you can download the CD images for Linux. So what I'm going to do here is to set up my capture here. First thing you want to do is obviously you want to put the parameters in here for your host. So in our case, the host is 192.168.57.24. And the source network is going to be a host. Now, in this case, if you need to capture from a spectrum of addresses, like say from an entire subnet, you can do that here. Obviously, you want to try to be as specific as possible. So in our case, we're going to capture the host since we know the specific host we're going to. And then as far as the destination host, in this case, this isn't generating a whole lot of traffic to anything right now because it's in a lab. So I'm just going to say go ahead and capture all of his traffic. Normally you're probably not going to want to do that if you know the host you're going to. You'll want to go ahead and put those in here and kind of define that, like I said before, because you only want to capture just the traffic that you need. But in this case, we'll leave this way. So then we click next, and now we have to pick the point of egress. Basically, we need to tell the ASA, so which interface is my traffic when it goes through going to come out of. In this case, we're going to pick the outside, and you'll see that our parameters that we put in there from before are still there, so we don't have to change any of these. So then we're going to click next. I will check this. You don't have to, obviously, but you can set it so that basically it will go out and poll the firewall to see if any packets have been captured, basically. The other thing you can set here too are, like if you only want to catch, smaller packets, to save space. You can also mess with the buffer size here. I usually just leave these at the defaults. Now what this step shows us here is if you were doing this by command line, you can see these were the commands that you would actually have to enter into the command line version of the firewall in order to actually set up this packet trace. And by looking at these, it looks like there's like about 8 different commands. So you can see why, as I was saying earlier, using this wizard is a lot easier than trying to do this through SSH. So we're going to say next. And then we're going to go ahead and click the start button. And it looks like it wants me to log in again for some reason. This is interesting. Looks like we're having a little technical difficulty here, so let's see if I can figure out what's going on here really quick. Could be that we have someone else logged into the firewall that's looking at things. Okay, I'm going to go ahead and set this capture up again here real quickly. See, and I just made that mistake I was just telling you guys about it, not watching that change up there. There we go. Okay, now let me go to my host here. Let's see about generating some traffic here. So let's say we want to download. We're on, as you can see here, we're on the public FTP here, and we're just doing some changing directories and stuff here. You can see we got that, so we should see some traffic, and see, there you go. If you click on this get capture buffer, basically what it'll do is go out and pull what's already out there, and then you can see here that we have data here. You can see that it actually picked up those packets from where I was communicating out to the server there out at NC State. Now, if in a lot of cases, you'll be able to see here, but just by seeing this, you'll know traffic's going, and sometimes that's really all you need. Like, you need to be able to prove it to an app vendor or something like that. But sometimes you need to actually sit there and like look at this capture in a tool like Wireshark or whatever, or you may need to save it to send it to someone else. Well, you've got an option down here where you can actually save this capture in it. You can download it basically in PCAP, and then you can actually pick which of the two that you want. and you can actually download those and save those as a PCAP file on your local machine. Now, the other thing you can do that's really nice is if you have Wireshark installed on your computer, which I do here, you can just go up here and say launch sniffer application. So as you can see here, I just loaded Wireshark and it automatically pulled it up and opened it. Basically, it went through the ASDM, basically downloaded the capture to my local machine, and then it also starts Wireshark and basically puts me right in a place where I can sit here, and you can see here, my traffic basically going back and forth here. So like I said, fairly simple to do this. In fact, it's probably one of the easier things you'll have to do on an interface, on an ASA, as far as administration. So once you're done, or if you need to say you're still capturing and that wasn't what you needed, but now I want to go back and have the person try it again or whatever, you can actually clear that capture buffer by using this button down here where it says clear buffer. Now when you click finish on this, what it's going to do is it will actually go back into config and remove those commands that you saw that it put in there, and basically kind of clean up everything after itself. That's the other reason I like doing it here instead of doing it in the command line. So now that we've covered doing packet captures, let's talk a little bit about doing packet traces, basically to check for issues. Packet tracer is a tool that you'll use to simulate the flow of a packet through the ASA processing and basically report back on how the ASA would handle the packet. Essentially, it's a simulator. Basically, what it's going to do is take traffic you specify, you'll tell it, address, port, things like that, and basically it's going to simulate its flow through all the various processes of the firewall and through the interfaces. And it's going to come back and it's going to tell you basically what happens to that packet. The one warning is, like, if you're going to simulate, like if you're having problems with ping or something like that, and you're going to simulate those, you're going to need to know your numerical ICMP message and reply types, because it's going to require you to punch those in the interface. Later on, I have a web link to a reference that will actually give you all of those if you don't happen to know what those are. So we'll do a little packet tracer demo here. So we're going to go back to our ASA here. The packet tracer isn't in the wizards, it's actually up here under tools. So if you go up here under tools, you'll see packet tracer, and you also see the ping and the traceroute commands up here too. So the packet tracer interface, it looks very similar to the packet capture interface in that I'm going to have to pick the direction of the traffic. So in this case, I'm going to simulate the traffic to the FTP server for my guy who's trying to get out to the internet. Basically, we want to see, is this firewall actually blocking his traffic? So it's like inside interface, because it's FTP, it's going to be TCP traffic, so we set it to that type. The source address is going to be 192.168.57.24. Source port, it requires one, but in this case it's going to be random because the FTP client's just going to pick one at random. The destination address, and because this is where it gets real interesting, because this is actually just a simulation and we're not actually checking his active traffic, really I could put any address I want in here to see if he's getting out to the outside interface of the firewall. So in this case, I'm just going to kind of use the Google address just because, it's convenient. And then we'll say port 21. Once you've got all that information in here, just click the start button. And basically what it's going to do is it's going to walk you through. You see this little animation where the packet's rolling through the thing, and you'll see these phase lists here. Basically, these are all the various options that it'll go through. And in this case, you can see the end result is the packet is allowed. So basically, if he's having FTP problems at this point and we've run this packet trace, we know it's not the ASA that's blocking the packet, and we know he's getting through to the outside. So obviously in our list of troubleshooting things, that cuts a lot of stuff out of, being as part of the problem area, just by doing that. So you can see how this is really useful. Now, I also have a rule set up in here just so I can kind of show you how this looks if it does get blocked for some reason. At least I had a rule in there. So we'll go ahead and add one here. And we'll say deny any on FTP. We'll apply that. So now if we go back and run that same packet trace, we'll clear it. And we'll say 192.168.57.24 to 8.8.8.8. Source port random, destination port 21. We'll say start. Now you'll notice this time you see these little red X's over here and it says result, the packet is dropped. And it'll say here, ACL drop, flow is denied by configure rule. And what you can do is you can go back up here and then you can expand these and see it actually shows you every step where it goes through. And you can see where it did a route lookup, routes, it has a route for it. It hit this access list, and essentially it'll even show you here the rule that it hit that denied that traffic. So again, very useful tool as far as being able to troubleshoot traffic flow issues. Now the other thing you can do is you can use Syslog messages for troubleshooting. If you have a Syslog server configured, basically you can use it to review your Syslog messages. The thing is when you're doing debugging, it's helpful to set your logging level to the debugging level. But one thing I'd like to point out though is you don't normally want to keep your ASA if you have a Syslog server at debugging level. And the reason why is because it does impact performance, and it also impacts how large your log files are. Generally, you only need logging set at like an informational level as far as just for general, keeping syslogs for security and monitoring reasons. The other thing is if you don't have a syslog server, the one thing you can do is ASDM does have a GUI syslog viewer that you can use to look at a live scroll of the syslog as it's going by. But the memory buffer isn't really that huge, so if it's a really busy firewall and you can't narrow down your search results in the log very much, it's probably going to be more helpful to have the syslog server. But I did just want to show you guys what it looked like. So we'll go back to our ASA here again, and then where you're going to find this one is in a different place. It's not going to be up here in the menu. It's here in this little button here that says monitoring. So basically when you click monitoring, you'll come down here and what you'll see is this tab here that says logging, and then you see this thing here called real-time log viewer. And basically what you're going to do is set your logging level, which it will set to debugging because it assumes that's what you want to do. I usually set the buffer limit to 2000 and then just click view. And what you can see here is it pops up a window basically that has kind of a live stream of the syslog messages hitting coming from the firewall here. And if you need to filter it like you're looking for a specific thing, like I want to see what's going to 8.8.8.8, I can go up here and just type in a filter string and then say filter, and boom, there we go. It shows me just the messages that apply to my filter. And you can pause this, stop it. You can even download these and save these if you need to. You can clear it out. Again, very useful from a troubleshooting standpoint. So let's kind of put it all together here. And like I said, this is kind of a more simplified version of that troubleshooting list I gave you before. Um, you know, and this is like, for example, in the case of the guy, who can't get to his FTP server. So this is an approach I would take to troubleshoot that problem, using that list. So the first thing I do is establish that traffic is getting to the ASA from his machine. In my case, I would just do a packet capture at the firewall on the inside interface, tell him to try his FTP command, and if I see his packets, then I know they're getting there. So then the next thing I would do is use the packet tracer tool in the ASDM to check if traffic is allowed by the current firewall configuration. Basically, by executing that command in packet trace like we did in our example, it will show you problems with that you may have in your configuration as far as not having the right ACLs, not having the right translations, not having the right routes, basically in your configuration on the firewall. And like I said, and it'll do that by simulating traffic flow through the firewall, and it'll show you if you have any problems, and if you do, where exactly they are. If he was still having problems and the packet tracer said his traffic was allowed through, the next thing I would do is basically perform a packet capture on the outside interface to establish that basically his traffic is actually egressing the firewall. A lot of times when you're working with a vendor on the other end, say the guy that runs this FTP server, you know how this is. A lot of times they don't just take your word for it. They want proof, so that packet capture of the packets going out, you can send it to them and say, hey, look, this traffic's leaving my firewall. I can show you that it's leaving here, and then a lot of times that's what's needed to get them to actually take a look at things on their end. So then the next part of it is exactly what I said before. I need the guy on the other end. Basically, now that I've proven that it's leaving my firewall, it's like, okay, now I need you to check, the FTP server on your end to make sure that you're getting the traffic and that your FTP server is then responding appropriately and sending the traffic out. And in a lot of cases, you will need a support person on the other end to do this. There's just no way around it. So he validates that all that is actively happening, but I'm still having a problem. So what do I look at next? Well, the next thing I'll do is I'll put a packet capture on the outside interface. And essentially the reason I do that is I want to make sure that I'm actually receiving his return traffic on the outside interface of the firewall. And one of the things that you'll look for here, if you analyze those packet captures, a lot of times what you'll see, it can tell you if you're having server problems on the other end, and sometimes you'll see your traffic go out, hit his server, and then you'll see responses either like ICMP error codes, like if he's got they're trying to go to a host address that doesn't exist or the interface isn't up, or sometimes like if the server's configured to block traffic from him, you'll start seeing TCP resets. And basically, if you see those kinds of errors, then you'll know it's probably a server-side problem. But if you see, his traffic, return traffic coming through, and it looks valid, then where do we go next? Well, the next thing I do is do a packet capture on the inside interface of the firewall, basically to validate that traffic is then hitting the translation and then being routed appropriately out the firewall interface. And kind of like what I say here, if you can see that all that traffic's going out and coming back in and it's getting that far and it's still not getting back to his workstation, then the chances are really, really likely that it's a problem on your internal network and that you've got a routing issue somewhere, or you've got ACLs on your core switch or something like that that's blocking the return traffic back to him. So here's some links as far as where you can go for additional information or support as far as doing troubleshooting with your ASA. One of the most helpful is the Cisco support community. They do require that you set up an account there, but it doesn't cost you anything to do that. You can set up an account out there, and they have forums that are dedicated to all the various Cisco technologies, and you can go out there and post questions, and other folks basically can help you provide answers, and they even have Cisco employees that monitor these forums and actually go out there and actively answer questions. I also put a reference here too to the ICMP packet types, so that if you're using that packet tracer and it's asking you, like, okay, I'm doing an echo And so what type is that? 0, just just for reference. But it's basically it's a helpful document that has those packet types. Obviously, if you have any questions as far as this presentation, or if you have special issues that you're trying to troubleshoot, or you say, for example, you have one of these issues, you think this kind of thing would be helpful as far as troubleshooting a connection issue one of your users is having, you need me to do like a go-to meeting or whatever to to walk you through doing this, I'd be more than happy to do that. I put my email address here and my telephone number here. And as always, you can just get in touch with us here at MCNC through the knock or whatever. They know how to find me as well. I'd also encourage all of you to go out and hit the feedback link here. There is one basically on the web page for the webinars. We take our the feedback very seriously. So if there are things you think we can do to improve, or other topics you'd like to see, that kind of thing, please go out there and let me know. Or if there are things I can do to make my presentation more clear, or that kind of thing. So questions. I'm going to kind of leave the rest of the time we have open here for questions. If anybody has any of those that they would like to ask. You're welcome, Paul. And same to you, Froy. Yeah, doesn't look like we have many questions here, so I'll leave it open here for a few more minutes just in case anyone does have any questions. And obviously the slide deck will be available out on the MCNC website, and I believe they also post a recording of this, so if you need to download that, or you want to go back and rewind it and go back and look at something, you can do that. Okay, it doesn't look like we have many questions, and we've kind of reached the end of our time here. So I'm going to go ahead and cut it off here. Thanks everybody for attending. I really appreciate your time and your patience, and look forward to seeing you guys on future webinars. Thanks.